Alright, I'm going to run through rationalizing denominators for a quick 7.4 review. It's one of the things we did in 7.4. Alright, real quick, if you have a square root in a denominator, like we do in the first example here, 6 divided by the square root of 3, then you can simply multiply the denominator and the numerator by the square root factor that is in the denominator. Okay, when you do that, you are going to get a product in the denominator that is a perfect square. The square root of 3 times the square root of 3 is the square root of 3 times 3, or also the square root of 9, you could write, and that's a perfect square. Remember, 2 of the same factor on the inside is going to make one of those on the outside of the radical. Okay, so multiplying the top and bottom by the square root of 3 ensures we get a perfect square root in the denominator that we can take the square root of, and simply multiply the same thing into the numerator so that we don't change the value of the fraction. Now at the end here you can see that I have 3 digits total, a 6 and a 3 on the top, a 3 on the bottom. We are only allowed to multiply, divide, or reduce numbers that are both in or both out. Right here I have a 6 and a 3, numbers that are both outside the radical. Those are numbers that could be reduced, and here I can. 6 divided by 3 reduces to a 2. So my final answer is going to be 2 times the square root of 3. And we're done. Alright, the next example, look down below. We've got 5 divided by the cube root of 12. With cube roots or higher roots, you have to be careful. You cannot just multiply by the root that's in the denominator by itself. Multiplying something by itself gives you a perfect square. We're not interested in perfect squares anymore. We're now interested in creating a perfect cube. So watch, here's a trick. Simply, let me scroll it up a little bit. Okay, rewrite that denominator, that cube root, but do it in a factored form. Okay, think about what prime factors are making up that 12. Well, 12 is 4 times 3, and 4 is 2 times 2. So you really have, in that denominator, 2 times 2 times 3. And all I'm doing is rewriting my denominator. Haven't changed what I have in the denominator. So at this point I'm not changing the top. Now we are trying to make a perfect cube. So I'm going to multiply the denominator by something, and I'll do the same thing to the numerator as well. But I need to think about, what is it going to take to get me a perfect cube? Well, we know in order to create a perfect cube, I need 3 of the same factors. So look at the types of factors I have right now. I have some factors of 2. I have 2 factors of 2. I need 3, so I'm going to multiply in one more 2. Okay, then I'll have a total of 3 2 factors. 3 of the same will make 1 2 on the outside. Okay, now look at the the next factor here is a 3. I've got 1 3. It's going to take 2 more factors of 3 to have a total of 3 factors. And that way, once I have 3 factors of 3, that's 3 cubed, that'll be a perfect cube. So there you go, I'll have 3 2's and I'll have 3 3's. That's going to ensure that I have a perfect cube in the denominator. So whatever I did to the bottom, I need to also do to the top. Alright, so let's watch this unfold. In the denominator, I will now have the cube root of, really, 2 cubed when I multiply, times 3 cubed. Okay, in the numerator, I will have 5 times the cube root of 2 times 3 is 6, and 6 times 3 is 18. I can see that I won't have enough factors, enough of the same of any factor, to be able to get something to come out. Okay, in the denominator, okay, 2 cubed is 3 2's on the inside. That is going to make 1 factor of 2 on the outside. 3 factors of 3 on the inside is going to make 1 factor of 3 on the outside. So the denominator is going to become 2 times 3 instead of the cube root of 2 cubed times 3 cubed. And then in the numerator, I've got 5 times the cube root of 18. Okay, and my final answer now, I'm going to have the denominator simply be written as a 6. So 5 times the cube root of 18 divided by 6, and there is your final answer. So that's an example of doing a cube root. You would do the same thing if you had a higher root, a fourth root, fifth root, something in the denominator. Make sure you have the appropriate number of common factors to make the right perfect power. Alright, look at the last one real quick. In order to get rid of a radical in a denominator where you have a binomial, okay, right now I have two terms. This only works if you have a square root, but if you've got a binomial in the bottom, then you need to multiply by the conjugate. The conjugate is 1 minus the square root of 2. When you multiply conjugates, you will get a nice product. Okay, in the denominator, watch what happens. We're going to FOIL this out, right? 1 times 1 is 1. Denominator. Okay, 1 times a negative square root of 2 is just negative square root of 2. The square root of 2 times 1 is a positive square root of 2. The square root of 2 times a negative square root of 2 is negative square root of, really, 4. Now you see radicals there are square roots in my products. However, I've got nice things, right? What do I have that's nice? Well, these square roots of 2, they're opposites. I've got a negative and a positive. They cancel each other out, right? So I've got the 1. Now the square root of 4, that's nice because the square root of 4 is 2. So my denominator becomes 1 minus 2, or negative 1. So while I multiplied and I did look like I was getting some square roots, in the end everything simplifies so that I have no square root left. Alright, so whenever you see a binomial and there's a square root in there, you're going to multiply by the conjugate to the top and the bottom. Okay, so now for the top, we need to go ahead and distribute 8 to the 1 and the negative square root of 2. So that would be 8 times 1 is 8. 8 times a negative square root of 2 is simply negative 8 square root of 2. And now we'll just bring that over. So I've got 8 minus 8 square root of 2. And dividing by negative 1, I can clean this up for a final answer here pretty easily. Just divide both terms by negative 1. 8 divided by negative 1 is negative 8. And a negative 8 square root of 2 divided by negative 1 becomes a positive 8 square root of 2. So there you go. Just a quick review on how to get rid of radicals that are in your denominator.